let's find a general solution for each differential equation. The first one is the square root of 1 minus 4x squared times y prime equals to x. So y prime is equals to dy dx. That is the derivative of y with respect to x, and then we have x. Okay, now there is a 1 minus 4x squared in square root. So I will just do one more step for you. So this is in a square root, and then I would like to keep all the x on the left hand side. So that means the next step, first I would like to divide both sides by the square root. So we have dy dx equals to x divided by the square root of 1 minus 4x squared, and then we multiply the dx to the other side. So we have dy equals to x divided by the square root of 1 minus 4x squared dx. So now all the y's on the left, all the x on the right, the separation of variable is done, and we are ready to take the integral. So nothing in front of dy, you can put a 1. You can put a 1 in there, so 1 times dy. So when you take the integral of 1 is equals to y. So this we have y, right? And then equals to, so how do you handle the other side? The other side looks very complicated, but it is just a u substitution. So let's do the u substitution in red. We let u equals to 1 minus 4x squared. Du is equals to negative ax squared dx, and then 1 divided by negative ax. Why do I put a square in there? Negative ax dx, and then we put a 1 over negative ax du equals to dx, and then we do a change of variable. We place this box to the dx. Alright, so let's move the y equal. So now we have y equals to, and then we have integral 1 divided by negative ax, and then we have x divided by the square root of u du. And then the x got cancelled, of course. So let's use a different color to draw that. The x got cancelled, and then this is the integral of u to the negative 1/2, right? So y is equals to negative 1/8. The integral u to the negative 1/2 du, and then y is equals to negative 1 over 8. The negative 1/2 plus 1 is past the 1/2. And then the reciprocal of that is 2, and then we add a c to it, right? And then we put the x back, so we have y equals to negative 1 over 4, and then x is 1 minus 4x squared, and then the 1/2 power, you can use the square root and then add c to it. So this is done. This is called a general solution of the differential equation. We don't call this particular solution because you don't know what C is yet. So this is called a general solution of the differential equation. So if you want to find a particular solution, so let's say x equals to 0 and y is equals to 4, and then you plug in the 0, plug in the 4 to the general solution, and then you solve for c. So whatever c equals to, so let's say c equals to 50, and then you plug in the 50 to the general solution, and that is called the particular solution. All right, so I leave that part to you. It is simple. Plug in the 0, you have a square root of 1, right? So that is equals to 1. Actually, I can just do it quickly for you. So that is negative 1 over 4, and then you have a 1, right? And then you plus c, and then you multiply both sides by negative 4, so you have negative 16 equals to c, right? Because this is 4 equals to negative, oh, actually, you know what? I was doing this too fast. Okay, we do it. Okay, erase that, so you have 4 equals to negative 1 over 4 plus c is a plus. I did a multiplication. 1 over 4, that is equals to c, and then this is a 4, right? 16 plus 1 equals to c, so you have 17 over 4, that is equals to c, and then you plug this in to the general solution, and that is called a particular solution. All right, so this part is extra. Let's go to the next problem. The next problem, you have y times ln x minus xy prime equals to 0. This is a pretty long problem. So first of all, let's put the xy prime to the other side. So we have y ln x equals to xy prime. Should we do that, or we should just leave that on the left? Because I usually leave the y prime on the left hand side. Okay, so I will just change my mind. You can move that to the other side. That is not wrong, but you can clearly just just leave that on the left. So negative xy prime, we move the other terms to the right. So minus y ln x. So once you multiply both sides by -1, you have xy prime equals to y ln x, and then you change the y prime to dy dx, so dy dx, and then you have y ln x, and then you have to move the dx to the other side, right? So you have x dy equals to y ln x dx. So x on the right, y on the left. That means you have to divide both sides by y, and then dy, and then divide both sides by x, then you have ln x divided by x, and then dx. So the separation of variable is finished. So this step, I will just use a different color and then label this step as separation of variables. All right, and then the next step is you do the integration. So integrate the left side, integrate the right side. The integral of 1 over y is ln absolute value of y. So this is ln absolute value of y. How about the other side? The other side is a u substitution. You don't need to do integration by parts. So the other side, let's do this in another color. So you just have to let u equals to ln x, and then du equals to 1 over x dx. All right, and then you multiply both sides by x du is equals to dx, and then the change of variable, you have to replace the dx with x du. And then you have that equals to integral. You have a u divided by x. The dx is x du. I know you can get rid of the x, so you have the integral of u du. All right, back to our problem. We have ln absolute value of y equals to the integral of u, so that is u squared, right? And then 1/2 plus c. So u is equals to ln, then you put the ln in there, ln absolute value of y, this is 1/2. The square root of ln, and then you add c to it. So this one we can solve explicitly for y. So you just have to say that there is a base e for the ln. So and then you have to do the e raised to the entire right hand side. So you have 1/2 ln x squared plus c, and then this side you have a y. And then what else? And then we do a little law of exponents. So I can review that for you. So let's say you have x to the n times x to the m, that is equals to x to the n plus m. If you have a base e to the n times e to the m, that is e to the n plus m. All right. So that means you can split that up to e to the negative e to the 1/2 times ln squared raised to the 1/2 times ln x squared, and then you multiply e to the c. Let's do that. Y equals to e to the 1/2, and then ln x squared times e to the c. And then in differential equation, a constant is a constant. So this is just a constant c, big C. All right, so that means you have a big C right in front of the e. So overall, final answer, big C e to the 1/2, and then ln x squared. That's it. So this, we box this, and then we call this general solution. So this is called general solution of the differential equation. What if you want to find a particular solution? Then you have to use an initial value. Then the problem has to give you an initial value or initial condition. So it's very simple. So let's say when x is equals to 1, y is equals to 10. And then you plug in the 1, you plug in the 10, you have 10 equals to big C, e to the 1/2, and then you have ln 1 squared, ln 1 is equals to 0, so that is c times e to the 0 power, e to the 0 power is equals to 1, so that is c, so that means 10 is equals to c, right? using this initial condition. And then you plug in the 10, y equals to 10, e 1/2 ln x squared. So this is called particular solution. And then of course, if you have a different initial condition, you get a different particular solution. All right. So that is the end of this video. If you think my instruction is clear and helpful, smash the like, share the video for me, subscribe to my channel if you are on your way out. Appreciate for your help and support. I will catch you all in the next lesson. Signing out.